Have you ever wondered, where did everything come from? How did the universe, with all its vastness and complexity, originate? These are age-old questions, the answers to which have eluded even the greatest minds of our species. They are the fundamental mysteries that have sparked countless debates, inspired countless works of art, and driven countless scientific investigations. One of the most widely accepted explanations is the Big Bang theory. It suggests that everything we see, every star, every planet, every galaxy, was once condensed into a single point of infinite density, and then, for reasons still unknown, exploded into existence. But what if we think of this not as a physical event, but an informational one? Like the first time a supercomputer is switched on, and an initial download of information occurs. Every byte, every bit already there, just waiting to be accessed. So let's dive into these fascinating theories and see if we can shed some light on the mysteries of our existence. Imagine a singular point, infinitely small, infinitely dense. Then, in an instant, this point explodes, expanding outward faster than the speed of light. This, my friends, is a simplified description of the Big Bang theory. Let's break it down a bit more. At the very heart of the Big Bang theory is the concept of singularity. This term refers to a point that is so incredibly small and dense that it's almost impossible to comprehend. This singularity, according to the theory, is the source of all matter and energy in the universe. So, how did we go from an infinitely small point to an expansive universe? Well, that's where the Big Bang comes in. Picture the singularity exploding, rapidly expanding outwards. This isn't an explosion like you might see in a movie with fire and debris. Instead, it's an expansion of space itself, stretching out faster than the speed of light, carrying matter and energy along with it. Now, you might be wondering, how can we possibly know this? Enter the cosmic microwave background radiation. This radiation is the afterglow of the Big Bang, a sort of echo of that initial explosion. It permeates the entire universe and can be detected with the right tools. The discovery of this radiation was a major piece of evidence supporting the Big Bang theory, giving scientists a glimpse into the universe's fiery birth. The Big Bang theory, in essence, is an attempt to explain our origins, to trace the universe back to its very first moments. It's a story of creation, of how a single infinitesimal point expanded to form the galaxies, stars and planets we see today, of how matter and energy came to exist in the vastness of space. And that, in a nutshell, is the Big Bang theory. But let's explore it a bit more. There's still so much to uncover about our universe's birth, so many questions to answer. So let's dive deeper, shall we? The Big Bang theory is a lot to take in, so let's break it down and examine its key elements. To start, we have the concept of cosmic inflation. It's a bit like blowing up a balloon, but on a cosmological scale. Imagine the universe as an infinitesimally small, dense and hot singularity. Then, in a fraction of a second, it expands exponentially, growing larger than a galaxy. This inflation smooths out the universe, making it homogeneous and isotropic, just as we observe it today. Next, we have the formation of galaxies. As the universe cooled down, it allowed for matter and energy to coalesce. Tiny quantum fluctuations became the seeds for what would eventually turn into galaxies, stars, and all the celestial bodies we see in the cosmos. This formation process was not an overnight event, but rather an intricate ballet that unfolded over billions of years. Then there's the cosmic timeline. The Big Bang didn't just happen and then stop. It set the stage for a series of events that led to where we are today. About 375,000 years after the Big Bang, the universe had cooled enough for atoms to form, leading to the cosmic microwave background. Fast forward a few billion years, and we have the formation of the first stars and galaxies. And another 9 billion years later, our solar system comes into existence. These key elements paint a picture of a universe originating from a singularity, expanding and evolving over time into the vast cosmos we see today. The evidence supporting this theory comes from various observations, such as the redshift of distant galaxies and the cosmic microwave background radiation, both of which suggest an expanding universe that originated from a hot, dense state. The Big Bang theory provides a compelling explanation for the origin of the universe. However, it's not the only theory out there. Now let's consider another idea. What if the universe started not with a bang, but with a download of information? Imagine, if you will, a cosmic supercomputer flickering to life for the first time. As it powers up, it begins to download all the information it needs to function. This isn't just mundane data we're talking about, but rather the very code from which our universe springs forth. This concept, which we'll call the initial download of information, proposes an alternative to the Big Bang theory. Instead of a cosmic explosion birthing the universe, it suggests that our universe came into existence when this hypothetical supercomputer was first switched on. Now you might be wondering, how could a computer download information that could create a universe? Just as a computer needs software to function, so too does the universe require certain laws and principles to operate. These laws, such as gravity and electromagnetism, dictate how matter and energy interact. The supercomputer, in this scenario, would download these laws and principles, effectively creating the universe as we know it. It's a bit like a virtual reality game, where the computer creates the environment and rules, and we, the players, explore and interact within this created universe. But there's a catch. Even the most advanced supercomputer has to process and organize its data. It can't recognize every piece of information it contains instantly upon startup. It needs to sift through layers of code and storage. In a similar vein, we face a challenge when trying to trace back to the exact point of conception of our universe. Just as we can't pinpoint the exact moment the first byte of information was processed, we can't definitively identify the precise instant of the Big Bang. This raises a fascinating question. Are we seeing a similar issue when searching for answers in the Big Bang theory? Is our inability to reach the exact point of conception akin to a supercomputer's struggle to recognize every byte of information instantly upon startup? So, could our universe be the result of an initial download of information? It's an intriguing idea to contemplate. Both the Big Bang theory and the initial download of information theory present fascinating explanations for the origin of the universe. But how do they stack up against each other? Let's start with the Big Bang theory. Its strength lies in its ability to explain the broad strokes of our universe's past, present, and future. It tells us that the universe began as a hot, dense point nearly 14 billion years ago. It also predicts that the universe will continue to expand and cool. However, the Big Bang theory has its limitations. It struggles to explain what happened at the very beginning of the universe. We can trace back to a point of extreme density and temperature, but what came before that? What caused the Big Bang? These questions are still unanswered. On the other hand, we have the initial download of information theory. This theory suggests that the universe, much like a supercomputer, was turned on with all the information it ever needed. Its strength lies in its simplicity and its ability to provide an alternative view to the creation of the universe. It proposes that everything we know was set into motion in an instant, much like a computer booting up. However, this theory too has its weaknesses. It assumes the existence of a higher intelligence or an external source that downloads this information. But who or what is this source? Can this entity be scientifically proven or disproven? These are the questions that the initial download theory leaves unanswered. In essence, both theories present compelling yet incomplete explanations for the origin of the universe. They each provide answers to some questions while leaving others unanswered. They highlight the fact that our understanding of the universe and its origins is still evolving. Both theories, in their own unique ways, push the boundaries of our knowledge and understanding. Whether it was a Big Bang or an initial download of information, the origin of the universe remains one of the greatest mysteries of science. So, where did everything come from? The truth is, we may never know for certain. We've journeyed through the vastness of the Big Bang theory, the idea of all matter and energy bursting into existence from a singular point. We've also delved into the intriguing concept of an initial download of information, akin to a supercomputer being switched on for the first time. Both theories offer fascinating insights, yet both grapple with the same conundrum, the elusive point of conception. The Big Bang theory takes us to a point where everything is so densely packed, it's nearly impossible to discern what came before. The initial download theory, while captivating, leaves us pondering the source of the information. It's as if we're chasing our own tails in a cosmic dance. But don't let this deter you. Instead, let it inspire you. Every question, every theory, every exploration brings us closer to understanding our place in the cosmos. In the end, the mystery of our existence only adds to the wonder of the universe. Keep questioning, keep exploring, and who knows what discoveries await us.